Hello, in this video I'm going to solve question 2, problem set 1, lecture 2, lectures in elementary number theory. Let a and b be non-zero integers such that a to the ninth divides b to the fifth. Show that a to the fifth divides b to the 3 and a to the power of 12 divides b to the power of 7. Pause the video at this point and give it a try. Okay, for the first one, I know that this is guaranteed. I want to prove that this is also the case. I'm using the theorems that I presented in lecture 2. So that is not by no means the only way to do this problem, but these problems are designed based on my own lectures in the same playlist. Okay, so that's why I want to use the theorems that I presented in those lectures. So the first thing that I will do for this one, I raise both sides to power 5. This is possible because if I know a number divides another number, I can raise both sides of this divisibility relation to any natural power. So I raise both sides to power 5. The left hand side becomes a to the power of 45 and the right hand side becomes b to the power of 25. On the other hand, I know that b to the power of 25, according to one of the theorems we had before, divides b to the power of 27. Okay, and then from these two, by transitivity, I know that this number divides b to the power of 25, b to the power of 25 itself divides b to the power of 27, so I can conclude that a to the power of 45 divides b to the power of 27. Okay, but now I am allowed, so let me write it in this way. A to the power of 45 can be written as a to the power of 5 to the power of 9 divides b to the power of 27 can be written as b to the power of 3 to the power of 9. So in lecture 2 I told you that these common powers can be dropped. So in other words, I can take the ninth root from both sides as far as the leftovers are integers. So this means that a to power 5 divides b to power 3. And that is my goal. Okay? What about the second one? The second one, the idea is more or less the same, so the numbers are different. So here, I'm just giving you these exercises so that you can practice and improve your skills. Okay, so here what I will do, I'll raise both sides to power 4 this time. So the left hand side becomes a to power 36 and the right hand side becomes b to power 20. But the idea is again clear. Yes, here this time I have a to power 7, so I would say that b to power 20 is also dividing b to power 21. And again, according to transitivity, I can conclude that a to power 36 also divides b to power 21. But a to power 36 can be written as a to power 12 to the power of 3 divides b to power 7 to power 3. Okay, so I can take the third roots according to the theorem I mentioned, even though there I didn't present the proof. The proof will come later in the lectures. But then I can take the third roots from both sides of divisibility relation as far as the leftovers after taking the third root are integers. In this case they are, because if I take the third root from the left hand side, it becomes a to power 12, which is an integer because a was given to be an integer, divides b to power 7. b to power 7 is also an integer. So this is what we're supposed to have. Okay, again, the solutions that I am presenting here are by no means the only way. Probably you can find other ways. You can start from definitions, for example. But my goal is to practice the lecture that I am presenting. Okay, so these exercises are designed to practice on the material of the lecture presented on the same playlist in the previous videos. I hope this video was useful for you. Until the next video, be safe and goodbye. Thank you.